Hey, a warm welcome to day 43. Today you're going to learn some advanced concepts about classes and object-oriented programming. Plus, I'll make sure that you understand all the terms you have learned so far, such as attributes, methods, instance variables. So we have covered these, but I'm sure that there is still some sort of uncertainty on your part. You still don't know what is an instance variable, what is a method, and so on. Specifically, what you learned today is instance variables versus class variables. You'll know the difference. Instance methods versus class methods. You will learn to use properties, class properties. You learn static methods, magic methods, abstract classes, and abstract methods. And that's all you need to know about classes. So don't miss the videos of today, and I'll talk to you in the next one. See you. Hey, welcome back. In this video you'll learn how to create class variables. You have learned already how to create instance variables. So we have instance variables and we have class variables. I'll mention the difference between the two and show you what each of these are. We're going to work on the hotel booking app we've been building so far, but I'll simplify the main.py script a little bit. Actually, I'll just make a copy of this file, so please do the same. I'll name the second copy main2.py, and then in main2.py, I'll simplify the code a little bit. So I'll remove the two classes, credit card and secure credit card. I'll remove the entire loop where we run the program, and I'll keep only the two classes, reservation ticket and hotel. And also these two lines are pointing to the cards.csv file, so I'll remove those two. Now I'm also attaching this script to the lecture resources, so if you want to make sure that you have the same code as me, you can just copy that file and paste it in your project directory and name it with something like main2.py. So instance variables versus class variables. You have already created instance variables. Instance variables are these: hotel ID, name for the hotel, instances, customer name, and hotel for the reservation ticket instances. Now let me create a class variable and then explain you the difference between a class variable and an instance variable. Class variables are coded outside the methods of a class. Instance variables are coded inside a method, usually it's the init method. But class variables are coded here. For example, let's say watermark is equal to, let's say, the real estate company. This is the company that has this app, this hotel booking app. So they are a company who offer hotels for holidays, for people who go to vacation and so on. So that means now this text is basically part of the class. It's not specific to a particular hotel, right? That's why it is a class variable. Let me try to explain it better by creating some instances of the hotel class. So let's say hotel 1 is hotel ID is equal to, so this expects an ID, actually it's hotel ID. Hotel ID is equal to, well, let's give one of these IDs. Let's say 188. Let's create a second instance. Hotel 2, hotel ID. That's equal to 134. Make sure to give them as strings because we are loading the ID field as a string here, the ID field. These are read as strings inside Python. So 134, right? Now, if I print out hotel1.name and I execute the script, I'll get Snow Palace, right? That's the value of the name instance variable. So this is a variable of this particular instance. And now if I do print hotel2.name, we'll get tourist sunny apartment. So because name gives us different values for different instances, that's why we call that variable an instance variable, right? But now if you do print hotel1.watermark, and we do the same, let me duplicate this with Ctrl D or Command D. So let's do hotel2.watermark. You'll see that, of course, we'll get the same value for both these print functions. So that makes watermark a class variable because the value of the variable is shared among all instances. Plus, you can also access that variable using hotel.watermark. Execute. And you will see that we get 3 lines printed out. So hotel is the name of the class. So watermark belongs to that class. If we do print hotel.name, you're gonna get an error. So here we go. Hotel has no attribute name because name is an attribute of the instances. Now, what's the benefit of having a class variable, and when should you have a class variable? Well, the benefit is that the value of that variable can be shared across all the instances, as you saw. So that means if you think that all the instances should have access to one same value, as is the case here, so all these hotels are part of this real estate company. So the company, perhaps they want to print out that watermark, that label somewhere in the tickets or anywhere. So if you have an HTML frontend, for example, you have a web app and you want to display that label on the web app, then you could get that label from the hotel class like we did here, or from the hotel instances, depending on the scenario. So that's the difference between instance variables and class variables. So self is a variable. In the case of hotel1, it holds the hotel1 instance. In the case of hotel2, self holds the hotel2 instance. And then you get name out of self or watermark. So self has access to both watermark and hotel ID and name and so on. Yeah, I hope that's clear, and in the next video we'll cover instance methods versus class methods. I'll see you there. Hey, welcome back. In this video you will learn about the difference between an instance method and a class method. We did cover instance methods so far, so all these here are instance methods. Syntactically, you can tell that something is an instance method when you see that self is the first parameter of that method. Logically, what makes an instance method is that the method can be applied to an instance, right? So we can check here, for example, hotel1.available. So perhaps print out its output. Let me remove this last line because, as you saw in the previous video, that was to show you that that line produced an error. So now we should see true printed out of available. So the methods is an instance method because it can be applied to hotel1 and it can also be applied to hotel2. So an instance method is very tightly associated with its instance. So you are checking if this particular instance, this particular hotel, whose name is Snow Palace, if this particular hotel is available or not. The same goes with other methods such as book, you are booking that particular hotel. Same goes with reservation ticket, you are generating a particular instance of the reservation ticket, you are printing that out. But what is a class method then? And when would you need a class method? So let's create a class method here. To create a class method, you use the def keyword again, pick a name for the class methods such as hotel count, get hotel count. Now, instead of self with class methods, you write something like CLS. I'll cover in just a bit what CLS is, and then perhaps other arguments such as df or data. And then here return len data. So I just created a class method which will return the length of a data frame, which means that, for example, for this particular data frame, we'll get 3. This will return 3, right? Because this data frame has 3 rows. And lastly, to finalize this method, you should add the class method decorator just above the function. So don't leave any break lines here. This is a recommended style. So that decorator will basically change this method to a class method. Now CLS, this can also be self, right? Because it's just a variable. But to be in line with best practices, you should use CLS here. Because this actually will be a variable which will hold the class object, not the instance object. So everything in Python is an object, right? So when you go to a Python console, for example, and you do class A, let me pass just a simple class, A is an object, but A, the instance of A is also an object. So that means in CLS, this variable will hold the class. Now, why did I add this method here? Well, this method, as you'll see, so let me call it here, print hotel dot get hotel count underscore hotel count with parentheses, and it needs an argument. The data argument will be equal to df, our data frame, which is assigned here as a global variable, and run, and we get 3 printed out. So notice that I used hotel, the class, here, but you can also access a class variable using an instance. So hotel1 is an instance I've created up here, and if I run this, we'll get 2 3s printed out. 1 for that and 1 for that. Now you might ask, well, shouldn't this method also be an instance method? Well, not, because this is not related to a particular instance, right? This is related to the class somehow, so it's about hotels, but it's not related to a particular hotel. It's not related either to Tourist Sunny Apartment, nor to Snow Palace or City Break Inn. So whenever you need a method which is somehow related to the class but not related to an instance, then you want to create a class methods, and you use that class method decorator and that CLS parameter. And that's about class methods. I hope that makes sense, and I'll talk to you in the next video. Thanks. Hey, welcome back. So far you learned about instance variables and instance methods, and these two can also be categorized in the instance attributes category. So these are attributes of an instance. So instance variables and instance methods. Then you learned about class variables and class methods. These two are also known as class attributes, right? So we have instance attributes and class attributes. So attributes can be either variables or methods. Right, now in this video you will learn about properties, actually instance properties. So a property is a method which behaves like a variable. You'll see how. Let's go down to the reservation ticket class. We have two instance methods here currently, init and generate. And we will add another method which is going to be a property, so a special instance method called a property. So let's say that maybe the customer, they enter their name in lowercase letters and maybe they enter some unnecessary spaces when they type in their name. So we want to clean that out, to remove the spaces and capitalize the first and the last name of the customer. A good way to do that would be inside a property, and I'll explain you why. So let's create a method called the customer name. You see, this is not a verb. Because this is a property, it makes more sense to be more like a variable name. I'll explain why when you call that property. And then you say a local variable, so this is just a variable which has meaning inside this particular method. This will be equal to self.customername.strip. So the strip method removes any spaces. So let's say that the customer name is John Smith with some space at the end. What we're doing here is customer name.strip, and that will return John Smith without the space. Right? And then again we say name is equal to name.title. So name will be John Smith without space, and basically the second line we're doing this. So we get John Smith cleaned out with capital letters in J and S, and then we return name. Now this looks just like a normal instance method. To make this an actual property, you use a property decorator. I know you're still confused. What's the point here? Well, you'll see what's the point there. So let's create a ticket is equal to reservation ticket. That's the name of the class which has this property, right? Reservation ticket. It needs a customer name and a hotel object. Customer name, let's say the customer entered the name John Smith with a space and with lowercase letters. And hotel object is equal to a hotel instance, hotel 1 for example. Now with ticket.the customer name, you can access the returned value of the customer name. Let's print this out. Print that and see what we get as output. So we get John Smith with capital J and capital S. Now that means we can use the customer name inside here as well to generate the ticket. So self the customer name, right? And so the benefit of this is that you don't need to call this. That's what makes this a property, right? It behaves like a variable. It's defined as a method, but this decorator makes it behave like a variable. So let's call the generate method ticket.generate. Generate doesn't take any arguments other than self, so we should see the output with John Smith printed out on the ticket. And so that's about properties. So you should use a property when you think that the value this method returns looks more like an instance variable, but the value needs some processing. So you could also place these lines in the init function, so to modify the customer name by stripping it out and applying a title method. But that would be too much for the init function, for the init method. So it makes more sense to create a property and then you can just access the customer name as if it was a normal instance variable. So the benefit is that you keep this code enclosed inside a method. So that keeps things more organized. And yeah, that's about properties, and we have some more videos, so I'll see you in the next ones. Hey, welcome back. In this video you will learn about static methods. Let's create a static method in the reservation ticket class. To create a static method, you use the static method decorator, followed by the definition of the method. Let's say convert. Now you see that PyCharm didn't even suggest me to use a self argument. So static methods do not get a self argument or a CLS argument. A static method is like a function, so it doesn't have any reference to the class or its instance. Let's say we have amount as a variable and return amount times 1.2. Now what is this anyway? Well, let's imagine that we are generating the ticket, but we need some utility function to convert the price from euros to USD. So this is some sort of utility function, right? But since this function is somehow related to producing the ticket because we want to have that converted price inside the ticket, then it makes sense to have that method inside the class so that later on you can basically call that static method using reservation ticket dot convert, and here you'd give the amount like 10. Perhaps you store this in variable, convert it, and then you can use the variable somewhere else in the code. But let's just print it out in here, print converted, and so we get 12. So 10 times 1.2, we get 12. So that would be an example of a static method. Now the distinction between static methods and class methods is a bit blurred, but usually you want to use static methods when you want to do some utilities, like as we had here, converting that number. So conversions are usually a very used case, and so this method here is less associated with its class compared to this class method. Both class methods and static methods are rarely used compared to instance methods, but it's good to know what they are. So I hope this makes sense, and in the next video you learn about magic methods, which are very interesting, so I'll see you there. Everything in a Python program is an interaction between different entities. For example, we have libraries such as pandas, we have statements such as import, the return statement, the if statement, the else statement. We have keywords such as the class keyword, def keyword. Then we have classes such as this block of code here, that's an entire class. Then we had instances. This here is an instance of a hotel class. That's another instance of the hotel class as well. This string here is an instance of a string class. This other string is also an instance of a string class. Then we had functions, which are these outside of classes. And then we have methods, which are like functions, but they are inside classes, such as this method here and that method there. So a Python program consists of interaction between things like functions and instances and methods. Even when you do things like, is the hello instance, the hello string instance, equal to the hi string instance, even when you do that, what you're actually doing is you're calling a method. In this case, it would be this method, underscore underscore eq underscore underscore hi. And you get the same output. Actually, you are not the one who are calling this method. The interpreter is calling this method on the background. So this is implicitly called. And this here is known as syntactic sugar. You can think of syntactic sugar as simplified syntax, so that you don't have to write that method. You can just do hello is equal to hi, so that's more readable basically. Other examples would be 1 plus 2. That would be the equivalent of 1 space dot. You have to use a space with numbers because it can be confused. Python doesn't know if it's a float or an integer if you don't provide space. So that would be add 2 and you get 3. So when you do that, you're calling the add method actually. Now you can see a list of magic methods when you use dir. For example, dir hello or just dir str, and you'll see the methods available for str. Similarly, we can check for magic methods that our classes possess, because str is a class, right? Hotel is also a class. So let's copy this class in the Python console. You can either copy the entire class or you can import that class. But first, I'd like to remove all these. Right, just keep the definition of the classes here. Save the script, and then from main, that's main2 import the hotel class. Now hotel is available as a name in this Python session, and I can do dir hotel, and you'll see that the hotel class has all these magic methods. Among the methods, we will see underscore underscore eq. So as you saw, that was the equivalent of this operator. So let's try to use this operator with 2 instances of the hotel class. Right, just like we used here that operator with 2 instances of a string class. So hello is an instance of a string class. Hi is also an instance of a string class. So let's do the same here. Let's create 2 instances first. That would be hotel. You can either store them in variables or you can compare them directly. I'll store them in variables. So hotel, what do we need to provide? We need to provide the hotel ID. I'll just pass directly the value without mentioning the argument. You can do either way. So that would be 188, right? 188. I'll do another hotel instance and I'll provide the same ID actually. Still, these are treated as 2 different instances by Python. So if you do hotel 1 is equal to hotel 2, you get false. Why? Well, because these are basically treated as two different objects, and you can keep creating more hotel instances using the same ID. You can create 10 of them and you can compare any of them, and all of them will be different from each other. That is not the case with things like strings, right? Hello is equal to hello and we get true. That is because the class string, when it was defined by some developers in the core developer team of the Python organization, they have overwritten the EQ methods, so this method, and we can do the same so that when we compare hotel 1 and hotel 2, if they have the same ID, we will return false. That should return false. So let's do that in our code. Let's overwrite that EQ method, so we will change the behavior of that method. So let's go to the hotel class. Normally you add magic methods at the end, so after the last method, but make sure to be inside the class and write define underscore underscore EQ. The name has to be the same, exactly the same. You'll see this gets this special color in PyCharm. And now you want to specify how do you want this method to behave. So when do you want to treat two instances as being the same, as being equal? Well, I think if self dot hotel ID, so this ID is equal to self dot hotel ID, then we return true, else we return false. Save the script, then make sure to close this Python session. You need to reopen a Python session again, otherwise you will be working on the old class which doesn't have the EQ method. So import in a new Python session, import from main2, import hotel again. Create two instances, hotel 1 with hotel 188, and hotel 2 is hotel 188. Now hotel 1 is equal to hotel 2. Initially we're going to get an error, and I'm glad this error happened because now you can understand a key concept here. So let's read the error. It says hotel EQ takes one positional argument, but two were given. So hotel EQ takes one positional argument, which is true, right? It only takes self, but two arguments were given here. What is the second argument that we've given to this EQ method? Well, the second argument is the second instance, right? Because this here is the equivalent of doing hotel. Actually, it's the equivalent of doing hotel, the class dot EQ underscore underscore hotel 1 hotel 2. That's what we're doing. So we should reflect that syntax in here. So we should go there and add something like other. And then self should be updated to other here. So basically we are comparing this current instance, hotel 1, with this other instance, which is passed as the second argument, hotel 2 in this case. So hotel2.id and so on. Right, so save that script, close that Python console, import again. You can use the upper arrow key to call previously executed statements. Import hotel, create a hotel 1 instance, create a hotel 2 instance with the upper arrow key, compare the two, yeah, it should be this one, and we get true. So now we can successfully compare two instances and evaluate them as true if they have the same ID. So this could be useful in your program if you want to expand your program, for example, and you want to see if two hotel instances are the same. So to do that, you can just compare them like that, like you do with other instances types such as strings or numbers. So similarly, you can add more magic methods. You can overwrite more magic methods here. Perhaps it makes sense to add one hotel to another. So if that makes sense for your program, then you want to write exactly the behavior of what should happen when you add those two hotels together. So perhaps you want to access self.price if you had a price instance variable, which we don't have in this case, but if you had one, you'd do something like self.price plus other.price, so you could add them at a total. In a total variable, you could store them at other here and then return total. And then when you do hotel 1 plus hotel 2, you would get the total price as output. So that would be a number. So I'm deleting that, and so that just to show you how it would be if you use the add magic method. So that was some magic about Python, and you can try to experiment with more methods if you want to have some Python fun. And I'll leave this lecture at this point. I hope this makes sense and it gives you some more advanced knowledge about how Python works, the inner works of Python. And yeah, I'll talk to you in the next videos. Thanks a lot for following. I'm very happy to have you here. See you. Hey, welcome to the last video for today. Here you're going to learn about abstract classes and abstract methods. Yesterday, you do remember that I introduced you to a class such as digital ticket, which would inherit from reservation ticket. Yesterday, we simply wrote this in a Python console just to refresh your memory. So it was basically something like this, and then I showed you that you could override an existing method of the parent class. So generate is a method of that parent, and here you could return something else which is different from that. So let's say, hello, this is your digital ticket. Just an example. And you could of course have more methods such as download, and have some code here and so on. Now, this is not the best practice actually. A better way to do this would be to create something known as an abstract class from which other normal classes inherits. So this class would inherit from that abstract class which we will create now, and the digital ticket class would also inherit from that class. So let's create that abstract class here. This would have a name such as ticket in this case. And this would have the method generate, and it would have pass as code. And then the other classes such as reservation ticket would inherit from the ticket class, and same goes for digital ticket. Now we need to add something else to the abstract class to actually make it an abstract class, and I'll explain you why we call this an abstract class. What we need to add here is a parent for this class, and the parent is ABC. What is ABC? ABC is a class which we need to import from ABC. This is a module, a standard module, in Python, you import ABC. ABC stands for Abstract Base Class. Same goes for this ABC. So that's the module and that's the class. So ABC goes here. So now this is a child of an abstract class. And then in here we add the abstract method decorator, which also should be imported from ABC. Import ABC, comma, abstract method. So that should be the same as this here. Now, what's special about this class is that if you, let me try to show that to you in the Python console. So let's import that, and then let's define this class, or you can import it, but I'll just copy and paste it here. And then if I try to create an instance out of the ticket class, this class, right, so I am instantiating it. If you try to create an instance, you will get an error. The error is very specific. It says can't instantiate abstract class ticket with abstract method generate. So you cannot instantiate an abstract class because an abstract class is an abstract class. So it's a class which is not supposed to create instances. It's something abstract, and its role is to define a structure. Basically, it's not a must to use abstract classes, but it makes your code more clear. So you see, for example, now that, oh, this reservation ticket inherits from this ticket class. Oh, so you say, let's see what the ticket class is. And you see here, then you see that this has this generate method. And then you realize that every child inheriting from that class should implement a generate method. So that's a must now. So that way you basically are trying to define some rules. Perhaps you are collaborating with other programmers, so that makes it very clear that all the ticket classes, including this one in here, which also is inheriting from that abstract class, this also should have a generate method. So this way you are forcing the programmers, which could be you or another collaborator, to implement a generate method for each class, because that is a must. If the programmer doesn't implement a method, for example, let's try to create a PDF ticket here, which inherits from the ticket abstract class, and this has a generate PDF method. Let's pass for now, and it doesn't have a generate method. In that case, when you try to instantiate PDF ticket, you're gonna get an error. So this will not work, and that means it will force the programmer to actually remind themselves that they need to add a generate method. So it's good to use abstract classes when you see that it's a must that all those classes should have a particular method. That was about abstract classes and abstract methods, such as this one in here. Yeah, with that, you have a very complete overview of classes and advanced concepts about classes. As we move through the course, we'll have more real-world scenarios when we use classes. So basically, most of the apps we'll be building from now on will have an object-oriented programming structure using classes. That's why I introduced you to object-oriented programming during these last few days, so that now you're prepared to actually practice classes in more real-world scenarios. So thanks a lot for following so far, and please go to the next day and I'll see you there with building some more programs. Thanks!